Hello, College Algebra. We are going to be working on the final video of 4.5b, Rational Inequalities. In other words, this is part 3. Again, if you need a calculator and you don't have one in your hand, again, I would recommend going to this website, eeweb.com/tool/calculator. It has all the tools you need. And while I'm not going to be using it in this video, I got my own handy calculator. But if you need it, the website is right there for you whenever you need it. So before we begin on part 3 of this video, I need to show you some bell ringer examples. I got 1/3 plus 1/4, and then I have another couple fractions that we need to subtract. So as you look at 1/3 plus 1/4, you guys can easily see that we cannot add these just yet because we don't have a common denominator. Now, some of you can probably instantly say, oh, we can easily find a common denominator of 12. But I'm going to show you a way to get 12 as a common denominator using a really cool trick. And this trick will actually be helpful in today's lesson. So what I'm going to do is I'm going to take the denominator of 4 and I'm going to multiply it to the opposite side. And I'm going to multiply it top and bottom. And of course, I'm going to do the same thing with the denominator of 3. I'm going to take it and multiply it to the opposite side. So multiply 3 top and bottom. And let's see what happens when we do that. So on this side, I'm going to have 4/4 times 1/3. So on top, I'll get 4, and on bottom, I'll get 12. Oh, look at that, common denominator of 12. Now let's check the same thing for the other fraction. Multiply 3 top and bottom, that's going to give me 3/12. And using that easy trick where you multiply the denominator to opposite sides, you'll get a common denominator. And thus, you can now finally add these two fractions together. Denominators are the same, so you know your final answer will have the same denominator of 12. You just need to add the top, 4 plus 3, which will give you 7/12. Now, does that work for every fraction example we have to add or subtract? Believe it or not, it does actually. So in other words, let me show you how we can use the same trick on the second example. So give me a second while I erase this. So you take a look at the second example and you notice denominators are not the same. Ew. I cannot subtract these until I have a common denominator. So what if I use that same trick from the first example, where I'm going to take x minus 1, and I'm going to multiply that to the opposite side. But of course, you got to multiply the top and bottom. And then I'll do the same thing with x plus 2 over here. I'll take it and multiply it to the opposite side. X plus 2 all over x plus 2. Okay, let's see what that does. I'm just going to erase this part just to see what that does. So, on this side, x minus 1, if I multiply that by 1, again, that doesn't really change anything. So I'm just going to leave that as x minus 1 on top. On the bottom, I'm going to have x minus 1 times x plus 2. I mean, technically, you could FOIL that if you want, but we really don't have to. For the time being, just leave it as it is. Leave it as x minus 1, x plus 2. Don't FOIL. Trust me, it'll make your lives easier if you don't. Okay, now let's do the same thing to the other side. So now I got to do 1 times x plus 2, which again doesn't change anything. That's still going to be x plus 2. And on bottom, I got to do x minus 1 times x plus 2. Again, don't FOIL, just leave it as it is. X minus 1, x plus 2. So those are my two results. That happens when I multiply everything in green, everything in red. And according to this, I'm supposed to subtract the two. But check it out. X minus 1, x plus 2, x minus 1, x plus 2. We now have a common denominator. It's not a pretty common denominator. It's absolutely disgusting, but they're the same. That's what matters. They're both x minus 1, x plus 2, which means we can now subtract these two fractions. And we can assume, as always, if these two denominators match, our final answer will have the same denominator of x minus 1, x plus 2. We just now have to subtract the top. We got to do x minus 1 and then subtract that from x plus 2. Now, my recommendation is let's first do with the like terms. Like here we got an x and here we got an x, and I'm supposed to do x minus an x. But of course, that's just going to give you 0, which means those cancel out. Now we can move on to the numbers, where I got -1 minus 2. So -1 minus 2, which should give you -3 on top. So there you go. You've taken care of everything on top, and you just get -3 with a denominator of x minus 1, x plus 2. So this is actually a very common procedure that will be used in this video. In other words, this little trick will help us whenever we have denominators or bottom fractions that are not the same. So keep that little trick in mind. It'll be extremely handy. And let me show you how to use it in the next example. So we're going to be doing what we did yesterday, where we're going to be solving, rewriting this so we get like 0 greater than or equal to something over blah, 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 blah. And then we're going to be taking that, doing top and bottom, set them equal to 0, etc., etc. Basically all the stuff that we did yesterday. It's just now, this time, look at your example and notice that we don't have a common denominator. So we can't even really do much with this problem until we find a common denominator. And to find a common denominator, use the same trick that we talked about in the bell ringer. Let's go ahead and take the x plus 3, and we're going to multiply that to the opposite side. So x plus 3, x plus 3. And then we'll do the same thing with x minus 1. Multiply that to the opposite side. Okay? All right, now we've done that part. Now let's do the actual multiplying part. We'll do this side first. Here I got x plus 3 times a -1. The -1 actually does make a difference. So I'm going to go ahead and distribute that. So -1 times x will give me -x when I distribute. And then -1 times 3 will give you -3, or -3. So that's what we'll get on top. On bottom, we got to multiply x plus 3 and x minus 1. But again, I'm not going to actually FOIL that. I'm just going to keep it like that. X plus 3, x minus 1. And then my inequality sign, we have a less than or equal to. And now I got to multiply the red on the right side. Again, I got to do -1 times x minus 1. I'll have to take the -1, distribute. So first I'm going to have -1 times x, which will be -x. And then -1 times -1, which will be +1. All right. And then on bottom, I got x plus 3 times x minus 1. Don't FOIL that, just leave it as it is. Okay. So now we got this. Check our denominators. We have a common denominator. They're both x plus 3, x minus 1. Booyah. Which means we can now combine the terms. So this one's a little bit different from the previous example. The previous example, if you look, had a minus in between, which means we had to combine like terms. This example has a greater than or equal to sign. So there's no addition or subtraction in the middle. It's an equal sign. And when there's an equal sign or a greater than in between, what actually happens here is we got to do opposite operations. Or in other words, do opposite operations to both sides. So I think what I'm going to do is I'm going to take everything that's green and move it over to the red side. Or I'm going to do the opposite operations to move everything from the green side to the red side. If you decide in the online homework that you want to move everything from the red side to the green, that's totally okay. Just for this example, I'm going to do the opposite operation from green to red. You'll see what I'm talking about in a moment. So I'm first going to take care of this minus x, and I'm going to add it to both sides. So in other words, this x will cancel, and when you combine these two x's, well, those will cancel as well. Okay, all the x's are gone there. Now I'm going to take care of this minus 3. I'm going to add it to both sides so that the 3's cancel on this side. And since everything canceled on the green side, that means the denominator cancels out as well. Basically, everything is gone on the left side of the equation. And since everything is gone on the left side, we can say that is 0. If everything cancels on one side, then that side just becomes 0. And then on this side, we got 3 plus 1 on top, which means on top we'll get 4. And of course, our denominator still stays as it is, x plus 3, x minus 1. Whew, and there we go. We now have what we need. We have a single rational expression set greater than or less than or equal to 0. And now we can do what we've always been doing since the first 2 videos. So let's go to the next slide. As you see on the next slide, I have the exact same function that we just got, 0 greater than 4 all over x plus 3, x minus 1. Of course, the x minus 1 is in the front instead of the back, but it doesn't really matter. It's still the same function. So now we can do what we've been doing for the past 2 videos. First, take the top and the bottom, set them equal to 0, and see what we get. Well, first, if you set the top equal to 0, you get 4 equals 10, or 4 equals 0, and there's no x to solve. You just get 4 equals 0, and that is definitely not true. So that means we don't have a top to worry about. So we just focus on the bottom, and the bottom has 2 factors. So we have to set them both equal to 0, and that will give you x equals 1 for the first, x equals negative 3 for the second. And since those 2 are bottom parts, as always, the bottom we set not equal to. And as always, the bottom always gets open parentheses. All right, and we don't even need to worry about parentheses or open or close brackets for the top because we don't have a top. So this is all we need. All right, so now we've done first 2 steps. Now we can move on to graphing and finding test values. All right, so let's go to the real number line. We're first going to put a border at positive 1 with open parentheses. Then we'll put a border at negative 3 with open parentheses. All right, we got our intervals. We got 1, 2, 3 intervals that we need test values for. For the first one, I'm going to pick negative 4. For the middle one, I'm going to pick 0. Again, you don't have to pick these numbers as long as they're not touching the blue borders. We should be good. And then last but not least, I'll have that the test value for the third interval is 2. All right, so now as always, I'm going to be plugging these in. So 0 greater than or equal to 4 on top. We're going to have x minus 1, x plus 3. And make sure I have that correct function. 0 greater than or equal to 4 over x minus 1, x plus 3. Perfect. All right, so first test value to plug in is negative 4. Let's see what happens. 0 greater than or equal to. Well, you still get 4 on top because there's nothing to plug in. We'll get negative 4 minus 1, negative 4 plus 3. Go from there, let's see what happens. Okay, we'll get 0 greater than or equal to 4, and then negative 4 minus 1 will be negative 5, negative 4 plus 3 will be negative 1, which then finally simplifies to 4, And then on the bottom, you got to do negative 5 times negative 1, not add or subtract, times negative 1, which will give you 5. So 0 greater than 4/5. 0 can't be bigger than a positive number, so that's a false statement. So the first interval is a flop. Okay, move on to interval number 2. 0 greater than or equal to 4 all over x minus 1, x plus 3. This time we're going to be plugging in 0. Let's see what happens. So 0 greater than or equal to 4. Plug in 0, you get 0 minus 1, 0 plus 3. 0 greater than or equal to 4. 0 minus 1 will give you negative 1, and then 0 plus 3 will give you 3. Simplify that, you'll get 4 over negative 3, which is basically the same thing as negative 4/3. And of course, 0 is bigger than a negative number, which means we're good to go, because 0 is bigger than any negative number. So the second interval passes, which means we can shade. So the second interval will be part of our final answer. One more interval to test out. Okay, so again, 0 greater than or equal to 4, x minus 1 times x plus 3. I'm going to plug in 2 to see what happens. So 4, and then I'm going to have 2 minus 1, 2 plus 3, 0 greater than or equal to 4, and then 2 minus 1 is 1, 2 minus 3 is 5, and simplify that, that's going to give me 0 greater than or equal to 4/5. And 0 cannot be bigger than a positive number, so that one is a flop. And all right, let's check to see if our intervals alternate. False for this one, true, false. Good. They alternate, which means we did this correctly. So then for the final answer, look at where we shaded. We shaded everything from negative 3 all the way up to 1. So negative 3, 1 is our interval for the answer. And at 1, we have open parentheses. And at negative 3, we have open parentheses. And we don't have any other intervals, so we don't need a union symbol. So that's our Hawk's answer. Everything between negative 3 and 1, everything between negative 3 and 1 will satisfy this equation. Again, this is just stuff we've been doing for the last 2 videos. What our main focus today is dealing with expressions that don't have a common denominator. Like this example. Look at the denominators, they're not the same. So we have to make them the same before we do anything else. So to make them the same, let's do the trick that we did at the very beginning. I'm going to take this denominator, I'm going to multiply it to the opposite side. X plus 3, x plus 3. Then I'm going to do the same thing to this denominator. X plus 1, multiply that to the opposite side. X plus 1, x plus 1. Okay? All right, let's do that and see how this goes. I'm going to do the green side first. So this time, as I said before, don't worry about foiling the bottom. Just keep the bottom as x plus 3, x minus 1. Or x plus 3, x plus 1. The bottom, keep that as it is, x plus 3, x plus 1. The top, however, we actually do need to FOIL. Trust me on this. The top, we need to FOIL. So when we FOIL, we got to do first, outer, inner, last. If we do the first, that's going to give us x squared. If we do the outside, x times negative 1 will be negative x. And then 3 times x for the inside will give you positive 3x. and then the last terms, positive 3 and minus 1, which will give you minus 3. So that's what we do when we get the top for the green side. And our inequality is less than. Now let's do the red side. Okay, so this time we don't have to FOIL, we can just distribute, since it's just x times x plus 1. So for the top, x times x will give you x squared, and then x times positive 1 will give you just a positive x. And for the bottom, you don't have to FOIL the bottom. You just keep it as x plus 3, x plus 1. Okay, so this is what we got. And also, while I'm at it, I'm going to go ahead and combine these like terms. That's going to give me 2x. So I'm going to rewrite the top part real quick so that it combines the like terms. So I should have x squared plus 2x minus 3. Okay, I combine the like terms, and I should get x squared plus 2x minus 3. All right, so now I either got to move the red side over to the green by doing opposite operation, or vice versa. Last time I moved the green over to the red, so this time I'm going to do the opposite and move the red over to the green, just to show you can do either or. So let's do that. I'm going to take everything in red, move it over to the green to do opposite operations. So first, I need to get rid of this x squared, which means I need to subtract it to both sides. So everything in the red, or that canceled on the red side. On the green side, these will cancel as well, which is nice. Now I need to get rid of this plus x. The opposite operation would be subtracted to both sides. So everything, so that cancels on the red side. So everything on the red side canceled, which means the denominator would cancel as well. So nothing is left on the red side or the right side, so I'm just going to put that as 0. So 0 less than. On this side, however, we combine the like terms, negative x plus 2x, that's just going to give you 1x, or just x. And the minus 3, we didn't do anything with that, so that can just drop down. So we get x minus 3. And of course, your denominator will stay. So you'll get x plus 3, x plus 1. And there we go. We finally have one rational expression on one side and 0 on the other. Now we can use this to do our normal routine. And you'll see on the next slide, I have exactly that function. X minus 3 all over x plus 3, x minus 1. So now let's just do our old routine. Take the top, set it equal to 0, and then take the bottom, set it equal to 0. Hold up, I gotta check something real quick. Yep, we're good. Okay, moving on. Sorry about that. Okay, so the top equal to 0. That's going to give you x equals 3. For the bottom, you got two parts that need to be set equal to 0. So we're going to have two bottoms. We're going to have negative 3 and negative 1. And as always, those cannot equal for the bottom to be 0. And as always, open parentheses. There you go. Now for the top, however, the top will have parentheses depending on our inequality. And our inequality is strictly less than, which means open parentheses. Okay, we got all the tools we need to start graphing and finding test values. Let's scroll down a little bit. So for the top, we're going to have a border at 3 with open parentheses. Good. We're going to have a bottom at negative 3. Or in other words, a border at negative 3 with open parentheses again. And then we're also going to have a border at negative 1. And negative 1 will also have open parentheses. All right, we got 1, 2, 3, 4 intervals to test. So that means we got to have 4 test values. Here, my test value, I'm going to pick to be -4. For this one, it's probably safe to say the test value will be -2. For this interval, I'm going to let the test value be 0. And then last but not least, the test value I'm going to pick to be 4. You don't have to pick 4. You can pick 5, 6, 7, 8, or yada yada, as long as it doesn't touch the blue border. All right, we have our 4 test values. Now we can plug stuff in. So my equation, to copy it down, is going to be x minus 3 over x plus 3, x plus 1, less than 0. Okay, so x minus 3 all over x plus 3, x plus 1, less than 0. Just double check. Good. Awesome. All right. Let's plug in our first test value, -4. See what happens. So -4 minus 3 on top, and then -4 plus 3, -4 plus 1, all still less than 0. Okay. On top, -4 minus 3 will be -7. On bottom, -4 plus 3 is -1, and then -4 plus 1 will be -3, all still less than 0. -7 will stay on top. On bottom, -1 times -3 will be +3. So you get -7/3 less than 0. And lucky for us, a negative number is smaller than 0, so that is a true statement. Thus, we can shade in that interval because it works. All right, now let's do the same thing for the second one. I'm going to go ahead and erase the work for the first one just to make room so it doesn't look sloppy. Okay. Okay. This time, we're going to plug in -2 and see what happens. So, -2 minus 3 all over -2 plus 3, -2 plus 1, all less than 0. Go from there. On top, -2 minus 3 will give you -5. On bottom, -2 plus 3 is 1. And then -2 plus 1 will give you -1. Multiply the bottom parts. You're going to get -5 on top. 1 times -1 on bottom is -1. And of course, minus negative plus positive. So this actually just turns out to be 5. But is 5 less than 0? It is not. 5 is supposed to be bigger, not smaller than 0. So the second interval is a flop. All right, halfway done. 2 more to try. So x minus 3 all over x plus 3, x plus 1, all less than 0. And this time, I'm going to plug in 0 and see what happens. All right, so plug in 0, you get 0 minus 3, 0 plus 3, 0 plus 1, still less than 0. On top, 0 minus 3 will be -3, and on bottom you'll get 3 and 1, which if you multiply will give you 3 on bottom. So the -3 divided by 3 is -1. And is -1 less than 0? Negative is smaller than 0, so that checks out. So thus we can shade the third interval where we plugged in 0. So that we can shade that as part of our answer. All right, last time, just to make sure everything is working properly and I didn't make any form of mistakes, I'm going to plug in the final test value. Plug in 4. All right, let's do it. So on top, I'm going to plug in 4. So 4 minus 3, 4 plus 3, 4 plus 1, less than 0. Okay, someone's being really loud outside. I'm going to be right back. Could you guys keep it down? I'm making a recording. Thank you. Sorry about that. Okay, where was I? So on top, 4 minus 3 will give you 1. On bottom, 4 plus 3 will give you 7. And then 4 plus 1 will give you 5. And take care of that. 1 is still on top. On bottom, 7 times 5 will give you 35. So 1 over 35, is that less than 0? Sadly, a positive number cannot be smaller than 0, so that flops. And thus, we have what we have here. We got true, and then false, and then true, then false. Everything alternated, so that means we're on the right track. All right, so let's see what our answer is. For our first shaded answer, it shades from negative infinity all the way up to the blue border of 3. So negative infinity, comma, negative 3. And for the brackets, we're going to have an open bracket at negative infinity, and then at negative 3, it'll also be open. Awesome. Now for the second one, we shaded all the way to the blue border of negative 1, and then all the way to the blue border of 3. So negative 1, comma, 3 for the second interval. And at negative 1, we got open, and at 3, we got open. And voila! And since we have 2 intervals, union! So that is that answer for the Hawks. Again, we've done this so many times in the past 2 to 3 videos. You could do this part in your sleep. Again, the new part for this video was dealing with denominators that were not the same, and we already did that. So, I just got one more example to show you, and then this video will be done. So now this example looks a little bit different because, well, we're used to seeing one or two rational expressions. This one has a rational expression, but then a regular number. But the way you can fix it is you can actually rewrite 6x as 6x over 1. And then do what you need to do. And of course, as you see, the denominators are not the same. So we still got to use that trick from before. And of course, the trick from before, take this denominator, multiply it to this side, which will give you x plus 5, top and bottom. Then you're going to do the same thing with the 1 as well. Multiply that to the opposite side. And let's see what happens. So on the green side, you're going to have to take the 6x and distribute. So 6x times x will give you 6x squared. And that's 6x times 5, which will give you 30x. And then on bottom, x plus 5 times 1 doesn't again really do much, so that's just going to be x plus 5 on bottom. No need to FOIL for that. And then our inequality is greater for the middle. Now let's do the red side. Here we have 36 times 1, which is just 36. And then x plus 5 times 1, which is just x plus 5. All right. And check it out. We have common denominators, which means we can now combine these. But again, we have an inequality, which means we can't just add or subtract. We got to do it to both sides. And for this example, since there's only 36 on this side, I'm going to go ahead and move it over to the green side by subtracting it. In other words, I'm going to subtract 36 to both sides, and then everything on this side cancels out. Nothing left on the red side, so the denominator's gone, so you just get 0 on the right side. And on this side, you get 6x squared, and the 30x and the negative 36, those are not like terms, so you can't actually add them together. you can just write it as 30x minus 36. And that's what we get on top. And on bottom, you just leave it as your denominator of x plus 5. Okay. However, we're good now so far. We have one rational expression on one side and 0 on the other. But there is a bit of factoring that we still need to do. And we do actually need to factor the top because it'll make it much easier for the top and bottom part on the next slide. This is a little bit different this time because, well, we got a number in the front. That's the first time we've had that before of a quadratic. This is the first time we've had a number in the front of a quadratic. And some of you are thinking, oh, Miss Shulin, does that mean I have to do the box method? Ew, Miss Shulin, why? Why? Relax. I mean, you could do the box method if you want, and you would still be okay. But there is a better way. What if instead I take out a GCF? What if instead specifically I take out a GCF of 6? Then what would that do to the fraction? Well, if I take out a greatest common factor of 6, that means for the rest of the fraction, I have to divide everything by that GCF of 6 to see what happens. So here, the 6 divided by 6 would cancel, which would just leave you with x squared. Here, 30 divided by 6 will give you 5x. And then negative 36 divided by 6 will give you negative 6. And on bottom, you still have x plus 5, all greater than 0. That looks a lot better. And not only that, now that you got the GCF of 6 in the front, this part looks much more easier to factor. With x plus 5 still on bottom, of course. So now, for this part, you need to take this quadratic, find two numbers that multiply to negative 6, and add to 5. So for negative 6, you can use 6 and negative 1, or negative 6 and positive 1. You can do 3 and negative 2, or negative 3 and 2. And which one, all these multiply negative 6, but which one adds to 5? This one. So in other words, in these parentheses, we're going to put plus 6 minus 1. Doesn't matter what order. And all of this is still greater than 0. All right, now everything is factored as smoothly as we can. So then this is what we can use to do our final procedure. And let's see, let's go to the next slide. That's exactly what we're supposed to get. 6, x plus 6, x minus 1, all over x plus 5, greater than 0. All right. Now let's get down to business. It's our last example of doing our normal procedure of taking the top and the bottom, setting them equal to 0. So for the top, looks like you got 3 parts. You got to set the 6 equal to 0, the x plus 6 equal to 0, and the x plus 1 equal to 0. So when you set the 6 equal to 0, there's no x to solve. So 6 equals 0, that's a false statement. So we're not even going to worry about that. But you can still do the other two. The x plus 6 equal to 0 should give you negative 6 for x. And then for the other one, you should get positive 1. And that's totally okay. And then the bottom, set that equal to 0. And you're going to get x equals negative 5. And of course, for the bottom, set that not equal and give it its open parentheses. All right. And then for the top, look at our inequality. It's strictly greater than, no equal to sign. So our two tops will also be open. Okay, we got all the tools we need. Now let's put those on the graph. First, we have a border at negative 6 with open parentheses. And then we have a top also at 1, which also has open parentheses. And then we have a bottom at -5. Uh-oh, that's going to mean we're going to have a really tight interval. Ugh, that doesn't look pretty at all. But sometimes this will happen, and sometimes you just got to do it. So it looks like we got 1, 2, 3, 4 test intervals. For the first interval, I'm going to pick a test value of -7. For this one, which is the most disgusting, I'm going to pick a test value of 5.5, specifically -5.5, because it's between -6 and -5. For this one, I'm going to pick a test value of 0. And then the last one, I'm going to pick a test value of 2. All right, one last time. We're going to be doing some plugging and chugging. And we're going to be using this equation. So 6 over x plus 6, x minus 1. All over x plus 5, and that's going to be greater than 0, correct? Correct. All right, first test value, we're going to plug in. It's going to be -7. Let's see what happens. So 6 times -7 plus 6. -7 minus 1. All over -7 plus 5. All of that still greater than 0. All right. Plug and chug. You might want to grab your calculator, see what happens. All right, so it looks like we're going to get 6 times -1 times -8 all over -2, which then, if we simplify, 6 times 1 times -8 will give you 48 all over -2, which -48 divided by 2 is going to be -24. Now, is that greater than 0? It is not. That is a flop. A negative cannot be bigger than 0. All right. So that takes care of the first interval. Now let's do the second interval. Okay, where my test value is now -5.5. We're definitely going to need a calculator for this one. So 6 times -5.5 plus 6. And then -5.5 minus 1. All over -5.5 plus 5. And all that greater than 0. Woohoo! Yeah, please, grab your calculators. So 6 times -5.5 plus 6, that should be 0.5. And then here, -5.5 minus 1 will give you -6.5. And then on bottom, -5.5 plus 5 will give you -0.5, all greater than 0. Okay. Now let's multiply everything on top. So 6 times 0.5 times -6.5. Which should give you -19.5 on top. And on bottom, you'll have -0.5. So take that, divide that by -0.5. That is going to give you 39 as your final answer when you simplify that. And is that bigger than 0? You are, yes. Yes, 39 is bigger than 0. So the second interval checks out, so we can shade that tiny little sliver between -6 and -5. Woohoo! All right, time to move on to the second half. I'm just going to erase this, draw my bigger line. Okay. Okay, now for the last two intervals. I got to type in here again 6 times x plus 6 times x minus 1 all over x plus 5, all bigger than 0. This time, we're going to plug in 0. This will be easier to plug in for sure. All right, so on top, we got 6 times 0 plus 6 times 0 minus 1. Not write that correctly. 0 minus 1 all over 0 plus 5, all still greater than 0. Okay, so now we got 6 times 6 times negative 1 all over 5, still bigger than 0. On top, 6 times 6 times negative 1 will be negative 36, and then on bottom you get 5, all greater than 0. And a negative number cannot be bigger than 0, so that is a flop. So the third interval flops out. All right, one last interval to try, and then we are done. Okay, let's do it. All right, last time, test value of 2. Let's see what happens. Sick? Okay, so 6 times 2 plus 6 times 2 minus 1 all over 2 plus 5, all greater than 0. So then you get 6 times 8 times 1 all over 7, greater than 0. Multiply everything on top. 6 times 8 times 1 will give you 48. On bottom, you get 7, greater than 0. And, well, you don't need to simplify 48 over 7. You very well know that that is bigger than 0, so that checks out. Which means we can shade the fourth interval. All right, so with that said, let's check. We got false, then true, then false, then true. Everything alternated, which means we did our work correctly. So now we can finally write down our final answer. For our first answer interval, we shaded everything between -6 and -5. So -6, -5. And both of them had open parentheses. So there you go. Our second interval, it started at the border of 1 and shaded all the way to infinity. So 1, comma, infinity. And open parentheses at 1 and infinity is always open. So there you have your two intervals. Union, because you got, again, two answers. You got to do the union, meaning this or that. And there you go. So that basically covers all the type of examples that you'll see on the online homework. Again, the reason why this lesson is so hard for a lot of kids is because they want to rush. As you have seen, each problem takes a lot of time to do. There's a lot of plugging and chugging. There's a lot of checking. There's a lot of rewriting. So the last thing you want to do is rush. Because when you rush, the chances are you're going to make a mistake and the whole thing's going to flop. So please, I know you want to rush and just be done, but if you rush, you'll miss points. It means you'll have to start the whole thing over, meaning it will take you more time. So please, the first time, just relax, take your time, double check your work, and you'll be just fine. And with that, you're officially ready to do the online homework for 4.5B. If you have any questions or concerns, please email me, and I'll help you out the best way I can. I hope to see you guys soon.